All right. Well, welcome everyone. Thank you so much for joining the sixth Indexer call. This is a call to kind of prepare for phase two as we have wrapped up phase one, and we'll be going over the cost model workshop. It's with my pleasure to introduce Zach from our team at The Graph to take it away. Thank you, Zach.
All right, thank you, Tegan. Let me start sharing here. Okay, hello and welcome everyone. Yeah, thank you all for coming. This is my first appearance in a workshop, so I'm just gonna introduce myself briefly. My name is Zachary Burns. I'm a member of The Graph, and I go by that 3% on both GitHub and Discord. And so without further ado, this is the workshop you've all been waiting for, because we are finally going to talk about how you can drive traffic to your index node and how you will get some of that sweet, sweet graph token flowing into your account. So what we're going to talk about today first is driving traffic to your indexer node, indexer selection. And that just means when a query is issued to the gateway, what indexer are we going to choose to serve that query? We'll talk about first, from a big picture perspective, what the framework and the thinking of and how the gateway models this problem, because it has to balance a lot of different selection factors. And it's kind of just a good idea, how to understand how we boil down those many different selection factors into a choice of a single indexer. And then we'll dive into some of the specific factors that actually affect selection. And then we're going to talk about something called Agora, which is a new language that we developed here at The Graph to allow you to price queries in a very flexible and powerful but intuitive way. When we're talking about Agora, we're going to run an evolving cost model through an evaluation tool that's going to score the effectiveness of your pricing against real query logs that come from the hosted service. And then finally, we're going to show you how you can then deploy that cost model that you developed to the query market. And after that, we're going to take some questions. All right, so talking about indexer selection. So think the way that the gateway thinks about this is that each subgraph is really its own market. And within that market, there's a set of consumers, which are usually going to be DApp developers that are willing to pay for specific queries. Each consumer will be operating with a different set of budget constraints, different query volume requirements, a different set of priorities, whether those priorities be economic security or low latency or what have you. Since each consumer has a different set of priorities, the core idea is to first convert the priorities that they have into a utility distribution. And once everything is converted to this common idea of utility according to the consumer's preferences, then it's relatively straightforward to combine those into a selection function. The actual factors that we convert into utilities are performance, price efficiency, reputation, economic security, and data freshness. So what do I mean by each of those? Performance is basically latency, right? How long does it take you to serve a query? Price efficiency is whether or not a consumer has the budget for a query to pay for it at all, and if so, how much they're willing to pay for better service. Reputation is things like whether the indexer has a long history of being in the protocol, or whether they're usually online, and other kinds of soft requirements that don't have an in-protocol corollary. Economic security is how much value that an indexer has staked, and therefore how much an indexer would have to lose if they returned a fabricated response. Data freshness is how far behind the indexing is from the chain head. We include a little bit of randomness and special sauce in order to just discover the latest data about lesser known indexers and to increase the overall health of the network. So diving into one of these more deeply, it'll just kind of give you a sense for how that will extrapolate into the other factors. I'll take performance for an example. we've taken into account things like the fact that the majority of users will typically leave a page after about 2 seconds if the data that they want to see hasn't loaded. So the utility of a query then, with a 2-second latency, is about 50%, because only 50% of the people will see it, right? And then near, say, the 200 millisecond mark, that utility is close to 1, and has diminishing returns after that, because most people will perceive a less than 200 millisecond response as being instant, right? And near about the 10-second mark, the utility approaches 0. This is all configurable by the consumer, right? They say if there's a different scenario and a consumer is doing data analytics, well, they might care more about price efficiency than performance, right? So each consumer can parameterize each of these things, but that's kind of the general framework under which it operates. So every factor has a similar setup, with thresholds being where you might get most of the utility from something, and then it has diminishing returns after that. We might add some more selection factors in the future as we fine tune the algorithm. All right, so once an indexer is selected, right, we have to determine what the price for an actual query is. And the way that you're going to be describing your prices is in this new query costing language called Agora. We've designed it to be pretty intuitive and easy to use, yet very powerful, because you can describe very specific queries that might be problematic, or use value-based pricing or cost-based pricing, and all that kind of rolled into one tool. The word Agora, in case you're wondering, it refers to markets in ancient Greece, and what name could be more fitting for setting the prices of queries in our query markets. All right, so the best way to introduce Agora, I think, is through some examples. So what I'm going to be showing here is I've got 4 mock terminals on the screen, and in the top left, I'm going to be writing a query model in the Agora language. And on the top right, we'll be setting global variables, which I'll explain more later. And then in the bottom, what we're going to do is run the query efficiency evaluation tool and output the results and see how changing our model affects how we price queries in the aggregate. So whenever we show a result, what's going to happen is that we ran the cost model over about 4 million queries from the hosted service. All right, so first I'm going to run it here on this empty model. So we have an empty model. We would run the cost evaluation tool, and we get a result like this. As you can see, there are 0 successful queries. Our model is empty. This is no surprise. And there are a little north of 4 million failures. It does show the kind of failure, that the query is not costed. And it's showing like what the total GRT value for those queries is. Now, the way that we're converting to total GRT value within this tool is just that there is a parameter that, or a configuration that you can set, which converts the effort that it took to run the query to some amount of GRT, just to give us something to anchor to. And then under those failures, it's showing some example queries from the logs that we failed to price. So the first thing that I'm going to do is I want to price one of those queries. So I'm going to take the one at the bottom, which says tokens first 1000 skip 0 ID name symbol. That's just GraphQL query that's being run against the hosted service. And I'm going to copy paste that into the model and set a price. So that looks like this. Our model now has a GraphQL query. The syntax starts with the GraphQL query going first, followed by a fat arrow, which you can see at the bottom, and that's followed by a cost expression, which is just set to 1. We can run that new model and see what happens. Okay, so we got 30,000 successful queries this time. That's how many queries matched the model that we made. And it shows us some additional stats, like how much value that we're charging over those 4 million queries, as well as an error, which is basically how much we would need to be profitable, having set this configuration parameter of how much GRT that we're trying to extract from a given amount of effort. It also shows a mean squared error, which is basically just a sense for how fair that individual query costs are. So we can see that from the total error that we're off by over 200,000 GRT per query, right? So let's adjust the model. We've only costed 1 GRT here. So I'm going to adjust the model. Basically, all I'm doing is I copy paste that error value into the per query cost. Now we have the same model as before. It's got the query. It's got a new cost, which was informed by the error that we saw output from the tool. And we can run that and see what the result is. Not bad. We're now extracting, over 2.5 trillion GRT. That's a lot better than what we had before. And our error has gone down to 0, which is not surprising because we just copy pasted the per query value amount that we needed into our model. And we can see though that we're still not pricing a lot of queries. There are still over 4 million queries that we haven't priced. So if you look at the query on the bottom which is one example of a query that we didn't price from the logs, it looks very similar to one of the queries that we've already costed, right? It says tokens first 1,000, skip 1,000, whereas the query that we're costing says first 1,000, skip 0. And because the query match is exact, it means that we didn't price this query. And that's a bit unfortunate. So let's fix that. All that I've done to change the model this time is instead of specifying that first is going to be 1,000 and skip is going to be 0, I've used the GraphQL variable syntax to match any value for that argument. Let's run that and see the result. So now instead of pricing 30,000 queries, we're pricing over 100,000 queries, which is 3 times as many as before. But our mean squared error has increased. That means that the prices that we've set for our queries aren't very fair anymore. This also is not surprising because we have set a fixed price for a variable query. So what we're gonna do now is fix that. So all I'm doing with this model is to then add an equation for the price that I'm setting for the variables that uses the variables that we matched in the query. So when we match a GraphQL argument with the variable syntax, it's called a capture because you capture that value. And once you capture the value of an argument, you can use it in any expression within that statement. So our mean squared error decreased. Well, actually, let's run that and show you that the mean squared error now is decreased. And our cost now reflects like this idea that if you ask for more value, with the first parameter being like how many results you're going to return, and the skip parameter being time that it takes to page over results in the database, right? If you ask for more things, then it's going to cost more. So our cost model will feel more fair to our users. And you can kind of imagine now taking an equation like this and turning it into a linear regression in order to tune the actual equation and maybe minimize your mean squared error. We look forward to see what you guys do. But there's still yet a lot of queries that have not matched. So let's enhance the model some more. So what I'm doing with this new model is I just added a second statement. The first statement, matched, I think, 100,000 queries. But for the ones that it doesn't match, the model is just going to fall through and execute and try to match the second statement. Let's run that and see what we got. So this time we priced over 1 million queries, which is pretty good. And you can get a sense now for how you might iterate on a cost model, supporting more and more queries, making the prices more fair, and just kind of trying to distribute prices evenly across a wide variety of use cases according to either the fairness of the price or according to how much it might cost you as an indexer to run the query. But we have another problem, and that is that our cost model is very rigid, right? We've got some hard-coded numbers in here, and maybe we want to update those things. So I'm going to write a new model that takes care of that. In this new model, I'm introducing a couple of concepts. The first is the when clause, which you can see in the second to the last line of the model. It says query pairs when $underload, and then specifies its own equation there. And then what this is expressing is that actually, so first, actually, if you look in the top right column, also, we've added a global for underload and set that to false. So what this is expressing is that when the server is under load, you might want to charge twice as much for that particular query. And globals will allow you to make rapid changes to a cost model in response to things like changing market conditions or traffic spikes or what have you. So you may choose, say, to send the value and update your cost model by sending the value for underload in response to monitoring metrics on your server and not have to send or develop an entirely new cost model. Excuse me. There are a lot of applications for globals. One that I definitely recommend is to use maybe a USD to GRT global or something that can make your prices intuitive to you. And allow you to respond to things like fluctuations in the token price. We've glossed over a lot of important details and features, but I think that this should give you a good idea about how the design is motivated, and Agora will be released with a full specification of all of its capabilities. So I'm gonna have a short pause for Q&A before I hand it over to Giannis, who's then going to talk about how that once you've developed this cost model, how you're going to deploy it. So do we have any questions?
Yeah,
so one question.
Yeah, and you go.
Sure, yeah. One question we had in the chat was just how the matching is working. So is it matching just exact queries, or what if there's, a slight, what if there's one less field or one more field in the query? How will the matching handle that?
Yes, the matching will, if there is an additional field in the, well, okay, so basically everything that's in the model has to match exactly. But if the query has more fields, those will match as well. That will be okay.
So is there, this might be getting too in the weeds, but is there a recommended ordering that you would have based on that for like how to order these selectors and like the cost model?
Yes, so based on that, I would recommend that you order the queries from most specific to least specific. So say if you wanted to charge more when a field is included, you would include that query with the field before a match that came later with the query without the field. And so that would be able to charge additionally for that extra field.
Cool. Someone else asked, are the selectors evaluated separately, or do they feed into the later ones?
They're evaluated separately. I think over the long term, we would like to explore adding new features, but it's going to be in response to how we see the cost model being used. So right now, you could handle things like situations where you would want value to flow by just making your cost model longer and having more things in previous selectors. But if we see patterns emerging, then maybe we'll add some features to kind of compress those patterns and allow value to flow into different things. But that's really going to depend on how we see the cost model being used during the testnet.
Yeah,
maybe one more question.
One thing you might see in production is that there's usually like a small set of queries per dApp that are being sent, and they're always kind of the same with different parameters, for instance, when like paging, for instance. So you will unlikely to have to write, like thousands of lines for any subgraph like this. but it's usually going to be, not few, but not like a huge amount of queries that you can match more or less specifically. I believe what we didn't mention also is that there is a catch-all rule. I think it's called default, that you could add at the end to like price any query that doesn't match. I was just thinking about this because if you haven't received any traffic yet, you won't get any traffic unless you set a cost for the queries in the first place. So you probably start off with a default price, see what kind of queries you get. Maybe there will be other ways to find out what kind of traffic goes through the system. And based on that, you can then iterate and extend the model.
And this is something that can be done manually or automated, right? So we would kind of see that as maybe even being a two-step process. So it might be that, in real time, your indexer agent or indexer service could be configured to, throttle a really problematic query that it's, seeing just based on, real-time stats. But then with a kind of a more of a careful eye, you would want to come back later and sort of craft one of these things based on, a deeper analysis of like, okay, where are my costs, and, what patterns are emerging between the queries that are problematic. Let's do one more question, and then we can loop back on if there's more questions on these after Yannis's portion. But the question was, can you describe briefly again, how does error work? So how should people use the error output from the model?
Okay, so so do you mean this failure section at the bottom, like where it says failures 3 million?
Yeah.
No, I think it's more like, how do you know that you're pricing, like the total
Oh,
error
the
in your
total
pricing?
error. Yes.
Yeah.
I understand. Okay, so what the tool has is a configuration parameter for the amount of GRT that you want to extract for a given amount of effort. And in the query logs, we've logged how much effort, which is basically just time that the query takes to run in the database, takes. So if you're setting a target for how profitable you want to be, you might set that that parameter to want to capture or to extract a certain amount of GRT over a given time, say. When you then run the model, which this is running over about 4 million queries, we're going to sum up each of the values that you charged for each query, and then compare that to the amount that you wanted to charge in the aggregate. And the difference between those is the error. So that gives you an idea of whether you're overcharging or whether you're not meeting your profitability or what have you.
And this is just an evaluation tool. So this isn't going to this isn't part of the model itself. This is kind of to help you write the model effectively based on inputs that that the model couldn't, right? Like you might know your other fixed overhead costs, you might know how much you're spending on personnel, and so you just have a sense for how profitable you need to be on a kind of per effort basis through the model.
And this is definitely not a guarantee of any sort. I mean, because one thing that's going to be really tricky about this is as you change your costs, well, you're going to get different traffic sent your way. So there's, it's a best guess based on running the queries through the logs, but it's more nuanced than this tool will give you.
The one last question I will address real quick was if there's any way that we can get the 4 million query logs. So we will give you a log, I believe, to help train off of and kind of learn this. It won't be the one that Zach's used because that's based off of production data, but we'll be basically coming up with, sample queries and constructing a log that you can at least learn the ropes of using this tool.
Yes.
All right, why don't we hop over to Yannis, and then if there's more questions on the cost model, we can kind of cover everything in the Q&A at the end.
All right, let's do it. So, one sec, let me just find play button. All right. So, in order to work with this, we're adding a few features to the components that you've already deployed in your indexer infrastructure. So for internal purposes for you to manage the cost models and the variables that Zach has shown. We're adding we're adding to the Indexer agents, Indexer management API functionality to manage and query the cost models that you've set. So that's then used by the Indexer CLI through a new set of subcommands under graph indexer cost. And we'll demonstrate those in a sec. So that's kind of the two sides of managing that. Indexer agent will then store the cost models in your database, and the CLI will manage them remotely or on the same machine, depends on your setup. And for the public interaction with this feature or integration of this feature, the index service will have a cost API that clients can use to query the cost models and the variables. This is important because the gateway, for instance, or the gateways, or in the future any other clients, will need to know what your costs are to send you payments with correct prices. And so they will need to occasionally poll your latest cost model for a subgraph, for instance, that the client is interested in or that's being queried. And so that's what this is for, similar to the status API that we already have. So where the gateway or client can ask for the status of certain subgraphs to know whether you are up to date or like advanced far enough in the indexing that you can be used for incoming queries with certain block parameters.
Jonas, you're sharing the wrong screen.
Oh, I am. Oh, no. Okay, one sec. Stop share. Where's Zoom? Thanks for alerting me. Oh yeah, it's because it's okay. I'm sharing the right screen, but I'm showing the wrong window on this one. One sec. How about this? So, yeah, I think you already saw this. Just smaller, probably. So the second part of the public features that we're introducing is that the cost model will also be integrated into the query processing, not but into the query processing in the Indexer service. So whenever you receive a query that comes with a payment, the Indexer service will then check that against your current query model and decide whether that payment is accurate. You can maybe define like a tolerance so that some queries will be accepted even if they are slightly below or above, of course, but below the price that you would like to receive for queries like that. And queries that are otherwise below your price will be rejected, and then the client can, for instance, ask for the new cost model. The Indexer service can automatically return the latest cost model if desired by the client, and then that way they can align the two sides, and maybe you'll receive the same query again with a better price, or the client can also go to a different indexer instead if they find that the price that you actually want is too high. So those are the two sets of features that we're introducing with this. And so if you just want to recap really quickly on the infrastructure that you've already set up for phase one. I've cut out a few things that are related, like Prometheus, but generally you still have the Indexer service, you still have the Indexer agent, you still have the Indexer CLI. All of that remains the same. All you will need to do for phase two is to upgrade these to releases that have the features I mentioned. And then there's a new graph indexer cost command in the CLI that you can then interact with. So no big changes, just upgrades. And new CLI commands, of course, that you will interact with. So let's walk through those real quick, and then I'll show you a demo of what that looks like in action. So similar to the rules, you can indexing rules, you can ask for all the cost models that you've defined, and that will return the models, the deployments that the models are for, and the variables. You can output that as in that table syntax, or as JSON, or as YAML, so that you can further process the output using tools like JQ or other shell tools. You can also get the cost model just for a single deployment. You can also get just the model for all the deployments, or for one specific deployment, or all the variables, or just the variables for a current deployment. That should give you a lot of flexibility in creating just what you need to then pipe into other scripts, or to render somewhere for then making decisions based on that. The counterpart to this, where you modify the rules, is just a set, really, because the model, the model is basically a document with a number of rules, and whenever you want to update that, because the formatting can be pretty arbitrary, you can have new lines in there as you want, and so on. It's probably easiest to just get the latest model, add a line to it, write to a file, add a line to it, modify some lines, and then push it back to through the CLI to the Indexa agent, and then so that the Indexa service picks it up. So you can set the models and the variables separately. The model is set from a file name, so you pass in a file name that contains the model data, and then the variables are basically JSON object string that you can pass in as a string or from standard input. And that is the management side of things. And then we have the cost API. So when we introduced the Nexus service, we didn't really cover the APIs that it provides to clients / the gateways. But I wanted to quickly show you what that looks like for the cost model, which is very similar. It's a GraphQL API served at /cost on the Indexa service. So that needs to be reachable. And then it has one GraphQL type, which is a cost model, which has a deployment ID. That's this hexadecimal version, but whenever it's displayed, it will be the IPFS QM something string. And then it has a model and variables. Both can be unset, in which case it's not very useful. But initially, you'll usually start off with a cost model that has nothing. So those are optional. Actually, now I think we can probably make the model required, because that's what you start with potentially. You can also start with the variables, so it's fine. And then when the gateway or any other client will ask for the cost models, they can do that either by asking for a specific deployments cost model, or it can ask for cost models for a set of deployments. This is for batching, to make it's a little bit more efficient, because the gateway will need to monitor a lot of different indexers. There's quite many of you, and so this will allow to reduce the number of round trips that the gateway will have to make to keep the cost models up to date, periodically or something like that. Okay, let's do a demo, and if I can somehow manage to leave the presentation. There we go. Cool. So we're going to go through the cost model management, and then we're going to look at the cost API. And for the management, the first thing you usually do is you connect to your Indexa agent. I believe I have one running already. So I just connect to that, and that's it. And then I can ask it for all the cost models, and I'll use this command to get me all the 3 different types of outputs. And initially that will be empty, I hope, because I cleared the rules up front. There we go. There's no data in the table view. This is an empty array in the JSON output format, and there's an empty array in the YAML output. So let's add a cost model. And so there's a bit of validation here, because as some of you have noticed initially in the Indexa agent and CLI, when you created indexing rules, there were some duplicates, and you couldn't get rid of the duplicates properly, and things didn't really work so well. So we've added more validation to that, and we're also doing validation here. So I think this one I may have to open in a terminal and run graph indexer cost set model foo bar. That will say, okay, the subgraph deployment ID here is invalid if I pass in a QM something string in, or a like a 0x, like hexadecimal string for the subgraph deployment ID. That'll be okay. Okay, but let's do the real thing. So what I'm doing here is I'm just creating an empty file that I call Uniswap Agora. And then I say graph index cost set model for, this is the Uniswap subgraph deployment that's currently used in the testnet, and I'm just going to set that model to this file. And if I run that, which happens in the background, I get this output, and it says that now the deployment, there's a new model for this deployment, but it's empty. And I could, there's no validation for this right now, so I could like pipe some data in there and like some random string. That'll be, we'll add validation to that as well. I could also, no, I can't. I think I've tried this actually. Does this work? Yeah, it does work. Cool. Okay, so now we have a model, and it should not be foo, but maybe it is. Okay, let's see if we can do the foo there. Cost and model, copy this one out. Oh. Okay. And that, wonder if that has foo in it still? No. Okay. Okay, let's continue. So now we have a model, and we can then add a rule to it. I'm going to do this in the hopes that it'll overwrite the existing foo model. So this the same syntax that Zach showed earlier, where we have a query for tokens first in skip, and we make the skip flexible using a variable, and then we multiply that with a cost for skipping, and yeah, subtract that by 100. It's just an example, and we write that to the rules file, and we update the model. So let's see what that looks like. Cool. So now we have a deployment with this model, and we have no variable. So the skip cost multiplier wouldn't actually work because that variable doesn't exist. We'll add that in a moment. Now we can add a second rule to that. So if we add one, I think what I changed here is this is a query for pairs with token 1 and token 2. And otherwise it's pretty similar. So we're just going to add that to this file and update the model. And now we have those 2 lines in there. And of course we can always do output JSON or something and get this back as JSON. Cool. We can also add a second deployment or a model for a second deployment. So in this case, it's then synthetics, just a query for issuers here. And now this will just print the one that we set. So now we have, it looks like I already had some rules in that file before. Let's see if we can reduce that to 1. Yeah, okay, there we go. So if we go back to indexer cost get all, if we do that now, we get a table of the rules for those 2 deployments, the models, and then a JSON string, a JSON array with objects, 1 for each of the models, and then the same in YAML. And you can then pass that with other tools. What else do we have? Variables. So variables, again, are set with the same kind of command, graph indexer cost, set variables deployment, and then pass in a JSON object. This will not work. I could demonstrate that, but it's not going to be very interesting. It'll tell you that this is not a JSON object. But if you make it a JSON object, like one that sets the skip cost multiplier variable that I've been using in those cost models, then we should get back to, in this case, 2 tables, because we're running 2 commands, and we should have those variables included in the models. So that's how the CLI works, and there's nothing else to it. Thinking of adding like a way to clear or delete models for deployments, and maybe an interactive like editing where you can where it opens and edit your like default editor and watches the file that it's created, and then as you save, it'll watch that. When you quit your editor, it'll push that back up. So that'll make things a little bit nicer as you go. Just wanted to also show the cost API that the index as service provides for instance, the gateway. I showed you the schema for that already. This is an example query for the cost model for a specific deployment, in this case Uniswap. And we can ask for the same kind of object that we've seen in the CLI with deployment model and variables. And then we can pass it with, for instance, JQ to pretty print it. And if we run that, this is what we get. It's just your standard GraphQL result, just like you would get it from GraphQL API, like a subgraph on the graph. And you can do the same with multiple cost models where you pass in multiple deployment IDs, and you then get an array of cost models back. And that's the cost API. And I believe that is all I have. So any questions about that before I hand back to Zach?
Yeah, we've got a few questions we could touch on. So we had one question in chat. Can the cost model be based on the result of a query or other stuff other than just like the features of the query itself? And I think Hadrian actually answered this correctly, which is that the cost model is basically designed to estimate the cost of the query up front, because the way that our state channels and negotiation protocol works is you agree to the price in the state channel a priori, right? Like the state channel doesn't know anything about GraphQL or about the query language or about evaluating query results. And so for that to be a kind of trustless transaction, you agree to the price up front, and the cost model is just basically helping you construct a bid that will be accepted by the indexer. Hopefully that answers that question. Another question, I think, was touching on default. So Hadrian asked, what happens when a query falls outside of the rules? And then I guess a follow-on to that was, is there an incentive for users to tweak their queries so they're not recognized? Would you or Zach want to start with the default part?
Yeah, so there is a way to capture a default query and price that. But more importantly, I think that what we've observed on the hosted service is that there will be problematic forms of queries that you really want to catch. But because the query must at least contain the features defined in the model, but may also contain more features, it's kind of difficult to actually tweak a query so that it would, in fact, fall outside of the range of what you hoped to catch, right? So if you add a field or reorder the fields or use query fragments or any of these things, the cost model is still going to catch those, and you'll still be able to price the more difficult parts of the query. I think eventually over time also that there may be automatic updating of cost models, and we'll be able to detect on the fly through an index node that queries of a new shape are coming in and how much that those shapes are costing on average and what the standard deviation is for those. And you'll be able to update your cost model on the fly in response to that. So I don't think that that kind of attack is going to be very problematic.
Yeah, one thing that's worth emphasizing here is that like everything you're seeing in the cost model, it's really a protocol, right? It's a language for communicating these costs, but the way that that gets interpreted on the consumer side and the way that that gets used on the indexer side is, very flexible. As Zach was saying, things could be set automatically, things can be set manually. One thing we may not have emphasized was also that you can update the cost model and the variables separately. So, you might have a cost model that gets sent down to the consumer once, let's say per day, but then there's some variables that get sent down maybe even on every query response, right? Because it's a way smaller payload. You could even do things like single out a single IP address. So if you wanted to scale up the cost specifically to an IP address that you recognized as an attacker, for example, you could actually, send down a variable to them that communicates, hey, for your next query, this is going to be more expensive. And you could imagine, ramping that up based on some heuristic while keeping the costs for other IP addresses low. For the most part, for users that are using the system normally, you're going to be updating your cost model probably far more often than these dApps are going to get updated, right? Because if you think about the pattern for a developer, they're deploying their app to IPFS, they're sending this to users, the queries are basically in the build that's been deployed. And so I think it's very unlikely that normal subgraph developers would try and look at an individual indexer's cost model and write queries to try and game those selectors. One question that came up earlier in your slides, Giannis, was the concept of globals.
Yeah.
I think so. We have globals in the cost model. I guess is how Zach was referring to the variables, but then you were setting cost models for multiple deployments. So are those globals for all the deployments cost models, or are they for a single deployment cost model?
I think this is a bit different. This is probably about whether there is like a global cost model as a fallback for when there isn't a specific one for a subgraph, similar to how we have indexing rules that are global in case there are no specific rules for a deployment. Haven't actually thought about that yet, but I think that could be worth doing. Kind of like, if you had to create, the alternative would be to create a model for every deployment that you are indexing that has a default rule that sets like a default price. One thing that I think needs a bit more thought is whether this like global cost model would also be merged into specific models. I think that could get a bit hairy, especially when it comes to updates and so on. But I think we want to make it easy for everyone to start with something and then build that up, and that could initially be just a global model where there's a default rule for everything, and then as traffic comes in, you create more specific models for specific deployments. We'll think about that. I think that's good, really good idea potentially. So
It's a good suggestion.
Yeah. Another
One
question.
short question. Oh, go for it.
Was whether file name should be local or can be remote URLs. I'm actually, I haven't thought about that either. I think a local file, you could just download that with curl, and then the second command could be to pipe it through the CLI. It could make sense to provide a URL so that it would download that behind the scenes. I'm open to that.
Question was, does the Agora simulator filter by deployment ID? So correct me if I'm wrong, but I think they're basically applied right now. They're applied at the level of the deployment ID. So the Agora, I don't think itself is aware of deployment IDs.
That's correct. What we would do though is just to have different log files for different deployment IDs, and that will be more efficient anyway.
Cool. Was there more presentation, or Giannis, you said there was another part?
Yeah, I'd like to show what the indexers can expect over the next couple of days. Should I share my screen now?
Yeah, we can pause any more Q&A until the end.
All right, so we've gone over the cost model, how you're going to use it. Over the next couple of days, what we're going to be doing.
I'm not seeing your screen, Zach. I don't know if you were meant to be sharing.
I'm sorry. I'm hitting the wrong buttons now, but I'll be hitting the right buttons soon. So stay tuned for that. Okay, we see it?
We're seeing your presenters preview.
The wrong one.
Lovely. One more try. and then we're just
Yeah, we
going
talked about this before the workshop because it happened in another workshop that we did, and we wanted to avoid this. And now it happened to both of us. Great.
Yeah, for those of you that aren't aware or haven't tried this, Zoom and Keynote play terribly together. So it's always a fun challenge doing these presentations.
It's not working. I think I'm sharing the wrong screen again.
Now it works.
No, you got it.
Okay, great. So over the next couple of days, we're going to be releasing all the tools that we demoed today with comprehensive docs for all of those. So you'll be able to get more questions answered there. We'll also be doing all of the development in the open. So if you've got questions coming up, feel free to open an issue on GitHub about the cost model or the tools. We're going to be releasing a sample of logs with private information like the query volumes for specific subgraphs or timestamps and Ethereum addresses, either randomized or scrubbed from the data altogether, so that anything sensitive can't be mined for secrets yet until you get real query traffic coming down the line. What's going to be interesting about that data set is that it gives you an accurate reflection of how substantially similar queries of that particular shape actually took to execute on the hosted service at some point in time. So you're going to have a lot of data that you'll be able to build your cost model with. And the idea here is that you can refine your approach over the next few days before we actually open up the fire hose of queries that is going to be unleashed in phase 2. So that's going to expect. And now I've got a slide that says Q&A, but our time is up. In any case, I'll send it over to Brandon and see what he thinks.
Yeah, I mean, if there's any burning questions, we can maybe take one or two. I guess in terms of logistics, we have another workshop, I believe, scheduled, Martin, for Tuesday or Wednesday next week, where we'll kind of be doing something similar, but we'll be going deeper into some of the economics that'll play into phase 2. I know there's been some questions in Discord around like how the rebate reward function works, and I think there's a lot of math equations in some of the earlier presentations. So we're going to try and to make those a little bit more intuitive and kind of run through some examples. So that's kind of what to expect next.
Yeah, there's another question which I was meaning to answer earlier, and I started typing, and then I think I stopped because I thought it would be a good one to answer, in spoken words for everyone. So the question was whether there's a span of time that the cost model is valid for, like waiting for an end of an epoch or something, or whether changes are immediate. This is off-chain and kind of decoupled from the epochs, unlike the allocations, which are needed to distribute rewards after a certain amount of epochs. So this can be changed at any time. You'll have the variables as like a cheaper thing to change over time that can be pulled with less effort by clients, whereas the cost models, as they grow, they are a bit heavier. You can think of them like that maybe. But you can change them at any time. Clients may have to adjust a little bit to when you're changing them. So they might send you some queries with old prices and then realize, okay, cost model has changed, update their cost model, or maybe they'll periodically poll the cost models and therefore only detect those changes after a bit. But generally, this is not, like epoch length wait until clients pick up changes in cost models.
Yeah, one thing to be aware of there, I mentioned that we're just defining the protocol, but the behaviors, behind the protocol are kind of emergent. So one of the selection criteria that Zach kind of mentioned was, reputation. And there's actually a few of the selection criteria that play into like how efficient the negotiation happens between the indexer and the consumer. So if you like your cost model is just changing dramatically, and like let's say a consumer is running off of its cached version of your cost model, that could lead to an inefficient, negotiation. It might take a couple round trips for a bid to get accepted. Well, there's a few selection criteria where that's actually going to hurt your score a little bit. So there is an incentive to kind of behave in a smooth and orderly fashion, not to, just dramatically blow up your cost model, every minute or two. But it's not enforced in the protocol rules. It's really more enforced by what we would expect to be the emergent preferences and behaviors of, both counterparties in the negotiation. So I think ETA for release is tomorrow, I believe, on some of these docs and the tool. But we'll follow up on Discord, when those are available. We'll have more details on the start of phase 2 in the workshop next week.
Great. We are over time, so thank you, everyone. Congratulations again on making it this far into the testnet. A lot of folks registered, and you are the ones that made it this far, so give yourselves a round of applause for that. As always, we can address any outstanding questions in the Discord, and thank you so much for joining the Indexer call. We'll see you next time.
Thank you all. Bye-bye.
Thanks, everyone.
Take care, everyone.